We're so lucky this morning to be here with the American Chemical Society student affiliates who are going to do a demonstration for us on crazy color chemistry. And we're here today with Miss Heath's second graders from Floyd.
Good morning, everyone. I'm really happy to be here. My name is Javier, and with me are Violetta and Maddie, and we're part of the chemistry club here at Virginia Tech. And today we're just going to show you guys what chemists do in the lab and how colorful chemistry can really be. Maddie is going to do something called chromatography using coffee filters. And in chemistry, chromatography is how chemists separate different things. And you can actually use chromatography to separate things like colors. You can see that colors like blue are made out of green and yellow, and you can separate like a blue marker using this color, a green marker using color chromatography to see colors like blue and yellow.
So today we're going to be doing green.
So what Maddie's doing is adding some of the marker to the coffee filter, and she's then going to put the coffee filter into a cone. And when you dip the cone into the water is going to go through the coffee filter, going up to something called capillary action. And the water is going to drag the different colors out of the green marker. And we're going to just let that sit, let that color, let the water go up through the coffee filter. So while these things do its thing, what colors do you think will come out of a green marker? And we're going to set these aside and look at them once they're finished. And our next experiment is the density tower, and Violetta is going to set that up for you.
So this big thing is what I'm going to be doing the density tower. And it looks pretty cool when I'm going to be finished. I'm going to put a bunch of different things that have lots of different densities, and Javier's going to see that a little bit.
So a density is basically how stitched together things are. So if you think of a forest, right, with a bunch of trees, you could say that is a forest with a high density. And if you compare that to a desert that has no trees, then you could say that has a low density when talking about forest. Everything has a density. This table, your computer, your marker, everything has its own density based on like how squished together the particles are. And things won't mix if they have different densities. So if something is more dense, it'll go towards the bottom of the column. If something is less dense, then it'll go towards the top of the column. So we have different things like honey, corn syrup, dish soap, water, vegetable oil, and alcohol. And we're going to see how these different things stack. So if we bring it closer to the screen, you can start seeing the different layers start forming. And that's because each that thing we added has its own different density. So the next thing we're going to do is drop some things into our tower and see where they're going to fall in.
Before we do that, you see how honey's right there at the bottom? Do you guys think that means it's more dense than everything else or less dense? If it's all the way at the bottom, if it's sunk. It is more dense. So it'll float all the way to the bottom. It'll sink to the bottom. And something that is less dense will just float right at the top. So this alcohol right here is actually the less dense out of all of these things that I added. So there's honey, dish soap, there's the water. So yeah, this is right at the top, so it's less dense.
So let's take a look at how our coffee filter chromatography turned out. So this one didn't really separate. We added green and it's still green. So maybe the markers were just green. We also made a purple one. And when we did the purple one, we could see that a purple marker was actually made out of things like blue and pink and purple stuff. So in a purple marker, there's actually more than one color.
How did you make that blue thing?
So we added a bunch of different things to the coffee filter, and one of them was corn syrup, and we added food coloring to change the color of the corn syrup into blue to make it easier for you guys to see, because corn syrup is normally very clear and hard to see.
How does it not mix up? That's my question.
Different densities don't mix together. Because the syrup is the most dense out of all of them, it's going to fall all the way to the bottom. And like Violetta said, the alcohol is the least dense. So it's going to float all the way to the top.
How come all those colors that you put in there didn't mix up to one color?
So like I said before, each are in different densities. Something with a bigger density can be considered or like more heavy. So the heavier floats to the bottom, lighter alcohol floats to the top. The corn syrup is heavier than the dish soap and everything else, so it's second bottom, but it's still lighter than the honey. So it's this concept, this thing called density that separates every color of the color.
What will happen if you shake up the container with all those different colors? Will it turn into a big color?
If we mix them, they will actually all start separating again. Not sure if you noticed, but when Violetta was adding the different things, they were mixing already because you're dropping it into more liquids.
Let's actually do one for you guys. So let's say I add more dish soap, right? So we said that was towards the bottom, right? So it's actually going to go through these layers and try to get towards the bottom. So let me add some more for you.
So you can see that it's actually going through the layers and it's slowly making its way to the green layer.
It's getting there. Most of it is getting there. Some of it's still here up at the top. But you see how it's still all layered? Nothing really mixes up. That's why. Because of density.
And the green layer has been getting bigger because the dish soap is reaching the dish soap layer.
What are the items you used?
Good question. So the first thing I used was honey. So that's the most dense, and that's at the bottom. So just normal honey, then I used cornstarch, or corn syrup, and we put blue food dye coloring in it just so you guys can see it. It's usually just a clear liquid. And then we used dish soap that I just put in there. That's here at the green layer. And then water with red food dye coloring in it. That's over here. It's kind of hard to see. And then I used some vegetable oil. And then the last thing I used was that rubbing alcohol. This is when if you get a cut in your mom or dad, it helps you clean up the cut that you got. You put some rubbing alcohol on it. It stings a lot, but it cleans it all out.
Yeah, and then not sure if you were asking about the other experiments, but coffee filters to help us with the chromatography and just markers to separate the colors from.
How did they get the markers to show the colors?
We draw a ring around the coffee filter. So we're just going to use purple again. So yeah, we just used a normal marker and drew purple coloring around the coffee filter. And we fold it into a cone. And then like what Maddie did, we have a cup of water. And when we add the cone to the water starts traveling up the coffee filter through something called capillary action, which you're going to learn like in middle school. So it's like pretty far away, but the water starts traveling up through the coffee filter and it takes some of the marker with it, and the different colors travel with the water at different like speeds. So they start getting separated.
We all had a very, very good time. We got to ask some questions and see some cool things.
Thank you.
Thank you.